Hello, welcome to more Haskell live coding. I'm going to do something a bit different this evening. I think recently I've been focused on kind of more practical Haskell, building the kind of apps I might build in other languages. So I've been doing things like looking at Servant for web APIs, looking at Persistent for talking to databases. Today I'm going to do something much less useful, but something probably a bit more interesting for me. I'm very interested in programming languages and type theory, but I'm actually not very good at writing compilers and interpreters. So I thought I might start looking at some of the tech used just for writing toy languages. And I thought I'd start with a stack machine, but I'm going to start with a very easy version of a stack machine, mostly because I don't know what I'm doing, but also because it's probably a good way to focus on the building blocks of the stack machine and not get too caught up in the language you're trying to write or some complexity of parsing it or whatever. So the plan today is to write a really simple calculator, but implement it in a really complicated way. And we'll take a look at the outline in a moment actually, but I'm going to start with a brand new project. So I'm going to make a directory and call it calci. And I'm going to say git init in here. And I'm also going to say cabal init, not stack init. Okay, and then I will say code and it'll open somewhere randomly. Full screen, that's not what we want. I totally trust the authors because it's me. Can we zoom in? Can we zoom in? There we go, we can zoom in a bit. Cool, okay. I'm going to grab the Cabal file and I'm just going to do some boring stuff before I begin. So I want to use ReLUs. I want to use HSpec, I think, so we'll have a test suite as well. And I'm going to split it into a library and an executable because then I can test the library independently. So I think, if I can remember the Cabal I looked up 2 minutes ago, we're going to say something like sorter. That is not the correct thing. HS source directories. Try again. HS source. Oh, it's the word source. There we go, like that. And we can say this is in source. And we can say build depends on, I think it's something like, actually we'll put the base stuff in the common, so we won't put anything to build depends for a second. Maybe we can say expose modules. And I don't know what it's going to be yet. I can do this block called common, I think, and we'll call it shared properties or something like that. And then I can grab this stuff, not quite all of it. So we'll say build depends on base and default language, and then we're going to add some GCC options as well. It's a little faff of starting a new project. It's not GCC options. What is it? Cabal GCC options GHC. Wow, what am I doing? It's probably going to be GHC options because this is not a C project. Right, and then we'll say something like all warnings. All warning is errors, and then it's something like all warnings is not actually all warnings. There's other stuff I need to pull in, so it's something like no implicit imports or something like that. It's not no implicit imports, so there's something I can do. No unused imports. I think it's the thing that I want. If we get this wrong, it'll come back and bite me later. No unused imports like that. And then here I say something to pull in those shared properties, and I can't remember what that is. That's what I was just looking at. Import is what I want. So import, shared properties. And then down here, here's that. And then we can just grab the import line and pop it in there. Okay. So I don't really want this. I want base hiding prelude. Actually, I can copy and paste this. I looked it up a second ago. So I want to use this mix in. Let's try that. Just copy and paste it. So I'm going to use prelude again. Copying and pasting gets me every time. There we go, slightly better. Okay. So it's not base heading prelude, it's... Yeah, I'm just going to grab their line. Okay, and then mix-ins. Just line these things up. Like so, I think. And then we seem to be out by 1 in our indentation, so we can just pull that in back by 1 space. Indentation obviously very important to get to line up. Okay, and then I think I also want test suite. Is it not test suite? Can I copy this again? Oh wait, it's test suite and you give it a name. This looks very old. But anyway, I'll try this. It's not test foo, it's test calci. We'll have that. We will also import shared properties. And need to tell it where it is. Main is test foo. I might copy it out of somewhere else because I'm not sure this is quite right. What have we got? We've got Bookie and it's got some Cabal file in there. So this is what I want basically. Yep. It's this anyway. I did not copy it. Okay. Can we paste that in? Yes, we can. Okay, cool. So test suite is not Bookie test, but it's calci test. Main is spec. Get rid of that. I can get rid of that. Get rid of that. And then we want this build tool depends thing. I also want to do the import. Oh, it's annoying. So all my indentations move slightly out, which is just going to really irritate me. Okay. So it won't run yet, but hopefully I can say something like Cabal setup? Or is it Cabal build I want to do? No, I probably just want to do build. And it should get upset because some directories are missing, but it should at least start installing stuff for me. Okay. Plan for today. So, I kind of looked up over the weekend, so I have a rough idea of what I want to do, I think. I want to start by taking an input string, 1 plus 2, right? It's not very exciting. And then I want to convert it to reverse Polish notation. So we're basically floating the operators to sit after the operands. So it'll turn it into... Actually, first we're going to tokenize it. So it'll be something like tnum1 followed by t plus and then tnum2. Bracket those. So I'll just turn it into a list of tokens. So we're going to use megaparsec to parse the input string. Probably would install that. And then it'll turn it into reverse Polish notation. So it'll be something like tnum1 comes first, and then tnum2 comes next, and then it'll be t plus. Okay, so this will become our list instructions in a sense. And then we want to execute that list of instructions. And what we're going to do is we're going to set up a stack. And initially it's going to be empty. Then we're going to take our first instruction. Our first instruction is tnum1. And because it's just a number, what it's going to do is push it onto the stack. So in this case, our stack will just become the number 1. And then tnum2, it'll push it onto the stack as well. That's what it does with numbers. Oops, that one. So our stack will have 2 and then 1. And then when we get to t plus, we're going to pop 2 things off the list. Right, so the stack at this point will be empty again, but t plus will have access to 1 and 2 as its operands. And then this will produce result 3, and we push that onto the stack. So the stack at this point will contain 3. Okay. And then with a more complicated example, so you might have 1 plus 2 times 3. When we convert that into tokens, I'm not going to write the tnums bit, right? But you're going to end up with 1 plus 2 times 3 is our tokens, and then we want to convert to reverse Polish notation, and that should come out as something like 1, 2, 3 times plus. I've got that right. So what it's basically saying is the higher precedence things should come first. And then when we execute this, we're going to push 1, 2, and 3 onto the stack, because that's just what we do with them, but they'll end up in this order. And then when we get to multiplication, that's going to pop 2 things off the stack, so it should be 3 and 2. And that'll leave a stack which is containing 1. Multiplying together we get 6, and we're going to push the result onto the stack. So the stack then becomes 6 and 1. And then we get to plus, and it's going to pop 2 things off the stack. So in this case, it should pop 6 and 1. And the stack at this point should then be empty. We'll add them together and push the result onto the stack. And the stack should then just say 7, which is the same result. Yeah, that's the correct result, basically. So that's what I want to build. And then we can look at brackets as well, which makes everything a bit more complicated. But the way that we do this transformation, or indeed this transformation, is an algorithm known as shunting yard algorithm. So we'll have a look at doing that along the way as well. So that's a plan of what I want to build. it's probably the simplest example I can find of building a stack machine. Okay, so is this working? We have an error here. No prefix matches K. Okay, so we're just missing some directories and some files. Let's bring a terminal. We can. Oh, also some errors here. Right. Okay, so let's fix those. So in the Cabal file, it's not errors, it's just error, I presume. Let's see, is that not stack Cabal? Okay, and then we can make a directory called source, and we can make a directory called test, and then Cabal build. Good. Okay, I think we're good now. Right. So where to begin? I guess we could begin with a test. The tests, there was a thing I had to do to get it to magically pick up all the tests. It was like cookie test and then spec.it. Yeah, it's this magic line. Don't know what it means really. I just know that it causes hspec to pick up any file ending with spec, basically, and the test directory. So we go test main dot, no, we call it spec.hs. Just paste that line in. Okay, good. Doesn't like it, but that's standard, I think. And then we can say in here, we can say other modules. Oh, I can't say it. We just can't type. And the other modules will be something like, I guess we can start with a parser. Okay, and then we can write test parser. Okay, we'll grab that. And we will import test.spec. I can't remember how to write specs. Test.hspec. No, test.h. Spec. No. Okay, I'm just going to go and look again. So what have we got in here? We got server spec. That should be enough. Good. Let's try it again. So we need to export spec and we import test.hspec. I didn't tell it about hspec. That could be problematic. That's why I can't import it. Okay. So back to the Cabal file. And I don't really need it everywhere, except I do for HLS. So we should say stack build. Whoa, Cabal build. It's coming in there, we're not to type stack every time. While it's installing, I'm just going to jump back to here. So we need to export something called spec. And then we'll create a function called spec, which I think is called type spec. I think this comes from hspec. And then we can say spec is do We're getting closer. Good. Okay. So, can we say it? Or do I need to also describe? Let's put describe in. Describe valid input. And then we say it should produce a list of tokens. And then we can say something like, we'll call it parse. Then some input string. So we can say something like 1 plus 2. And it should be, I think, for the specs. Then we should get a list. Oh no, it's not should be. I remember this from the parser test before. It was a little bit more complicated. Maybe not more complicated, but different. But if a parser directory we do should parse. Okay, I don't need a describe block. So it's going to be should parse. Let me get rid of that. So we're going to want to end up with tnum1 and then t plus. Just putting the t in to avoid clashing with my constructor names. And then we can say tnum2, and I don't need brackets anywhere. Okay, so this won't compile, so we need to write something for the parser. In library, then we'll export parser, I guess. So back to here. Parser, and then we can say build depends on megaparsec, because that's what I'm planning to use. Okay, go back to here. I'll just create under source. I'll create a file called parser. I'm going to say module. Oops. Parser will export a method called parse. Then we will import. I can't remember what the input path is for megaparsec. But here we can just say we will go from a string to a string probably. I need to look at how to use megaparsec again because I've totally forgotten. And parse is whatever. Okay. As well as that, I need to define my tokens, which I think I'm going to do in a new file. So this, oh, it's code for me. Okay, module tokens. And we will export a type called token, not token. And then the token is, and then I said it was tnum, which takes an int, or it is t plus, anyone I support so far. Okay. So, back to val, I can say expose modules is this, and also tokens. Then we go back to the test. Let's say import that, that's good. It's not good, it doesn't like the name parser. I might be able to fix that just by restarting, well, by fixing the dependencies and then by restarting things. Let's find out. Oops, Cabal build. I haven't told it yet, it depends on megaparsec, have I? No, I have here. Okay. This will also depend on megaparsec because I need it for the test functions. Bit annoying, I can't import this. Even though it's in the library. We could call it calc parser or something stupid like that. So here we can call it rename calc parser. Do that. Okay, does this help? No, it does not help. Oh, under that, I forgot to import the library. Set the library as a dependency, basically, my test suite. So it actually depends on Calki and on megaparsec. Which means that this shouldn't be called Calki, this should be called Calki XE. And I think Lariat's called Calki. Such great names. If I build it, nope. So what's going on? It can't find source for calc parser. Okay, good. Not good, but understandable. Okay, compiled. And then this is now very unhappy. I need this to restart. HLS. Let's see if it does restart successfully. Yay-ish. Okay, cool. We made some tiny progress. Pulling the tokens we defined. And should parse comes from megaparsec, I think, or maybe it's a separate megaparsec test. Let's look at what we did before. By we, I mean me. It's nice to be inclusive, isn't it? Cabal. So in the test bit, we didn't depend on anything. Interesting. Okay. So in the library, we have got megaparsec, but we don't have anything set up in the test suite. So we look at the spec here. It's test hspec megaparsec, that's why. Okay. test h spec dot megaparsec, which is not finding, which worries me. I think I might have missed something somewhere. Okay, so it's an hspec megaparsec as well. Let's in 12 file. And I'm going to put the spellings of everything because of HLS. No, not that. Let's go to here. Okay, cool. Ish. Right. So the parse method is not going to give me back a string. It's going to give me back some type, some parser type, where the output from that, the non-error output, is going to be a list of tokens. Okay, so again, just copying it out of here because that seems to be my best bet. So parsec void string is what I want, except this time I don't want parsec void string. I want parsec void list of tokens. So my parse duration here is actually this that I want, I think. Oh, I shouldn't call it parse because that's a method inside megaparsec. Okay. Right. So, a couple of things. Let's go into here. Okay, instead of calling it parse, I'll call it something. It won't be parse duration. It'll be parse, I don't know, calc equation. Actually, maybe that would work. Okay, and it's going to go. We're not going to return seconds. We're going to return a list of tokens. Can we not import token magically? We cannot. Oh, expecting one more. Argument to token. What? I thought token was a type in its own right. It is. Maybe I'm clashing here. Maybe the definition of token is coming from somewhere else. Let's call it annoying calc token. Is that enough to fix it? Yes. Okay, so it's just a clashing name. Back to here. Actually, it's going to be calc token. Okay. And we're going to say parse, I don't know. I just want some basic parser. Okay, so our outer thing is going to go string to either, but the other parts are going to have this type, I think. Yeah. Okay, so this will be the type of our parser. And then we can say parse equation, oops, prime. I don't like this naming. I'm going to rename this, no. Rename this to something like calc parser. Okay, this is going to have type parser and then list of calc tokens. So we got a better name for calc token. So parse equation. And we can just say, for now, we can just put your empty list. Okay. And then we can use it here. And then we'll export calc parser. And here, it needs to be calc. Ooh. That was a bit weird. Try it again. Calc parser. Don't do this to me. Fails like my keyboard is crashing. Common problem when live coding. Okay. What's the current error? Couldn't match type IO with HSpec core, blah, 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 blah. Expected type. Spec with actual type. Expectation. Get rid of that. Oh, I got rid of the wrong thing. I got rid of it rather than describe. So it returns a list of tokens. Okay. No instance of show for calc token. This is good, I think. So we can use tokens, and here we want deriving show and equal. Wow, okay. We have a test. Does it fail? No test task computer test. Oh, goodness sake. Tasks. I can't remember how to do this. This is going to be test, type of shell, command is command test, and give me some help here. So kind test is default true, and then it's like presentation. Yeah, there we go. Oh, okay. So echo false. I know what going to say. Will always focus fault panel dedicated. Should we use message false? Clear true. Pretty much the opposite of everything it fills in for me. Okay, can I run the test? Yes, I can. More than one test suite's passed. I don't believe it. Looks like it did not run my test. Okay. Let's stick it on in. It fails. And then we can say that one should be 2. Oh, so the types are. One should be 2. Let's hope this does not fail. Okay, so I wanted to write a stack machine, and I just spent all my time arguing with setting up a new project. And failing to run a test. Okay. Back to here. So we've told it build depends. Do I need to build depends? I didn't see it in the other projects or anything. I don't think I do need it. Can we clear these? We cannot. Good stuff. Literally a weird character in there. That's not great. Does that make any difference? Yes. Okay, cool. That's not better. I do need to add to build depends. I don't know why it wasn't in the other project then. Okay, it still isn't passing. Back to here. So we look at the test again. So this is just a module that ends in spec and exports spec. And we have got module test parser. Good. This is not what we want. Rename, it should be parser spec. Oh, it's not going to help me out because compile file is wrong, so let's fix that first. Okay, does that help? Yes. I don't know why it's not highlighted, but yes. Okay, so turns list tokens and it fails. This is the one I want though, right? We're trying an empty list, but we expect it to parse some stuff. Okay. Make sure that failed on its own. One example, one failure. Good. Okay. Let's go back to the parser then. So it's going to be something like parse a number or parse like literally the plus symbol and then some space in between. Mega parsec. I can't really use this. Don't really want the core features. Here's one example. Tutorials. Tutorial here. Just one example of doing some stuff. Wow. This is so unhelpful. This is what I want. So character A, and then there'll be a whole bunch of other similar things. So hopefully there'll be something in here. Oh, it's called char. Okay, and then we can grab space, or is it digits? Yep. Okay. And then how do we do, whoops, how do we do or? Is it, so it's choice, I think. And some. Okay, let's have a. Let me just grab all of this. Okay. Some. You can say here import prelude hiding some. And then here I think we can say choice and then give it a list. And then we can say int parser. And the other thing is just going to be char plus. It's going to be such a mess. And that's going to come back as t plus. Okay, everything is very unhappy now. This is not going to be parser int, it's going to be parser t int. Let's get rid of that. Why is this so unhappy? Tnum. What did I say? No. What was in tokens? Tnum and t plus. Oh, but it's going to be a cart token. It's not going to be tnum because that's construction of the type. Give it a bracket for a second. But we're actually going to say tnum of that. Ooh, like that. Getting slightly closer. So maybe rather than the choice, we can just see if the int parser works on its own. Okay, so we can return that, and probably needs to be pure at that point. It does not. Is it like cons was an empty list put into there or something weird like that? And just throwing brackets in? No. Okay. So int parser is going to be a single thing. Oh, I'm going to put in a variable. We can come back to this later. Right, so we should parse number one off the start, but not everything else. Progress, okay. So we can get the first number. This is good. What do we do next? So then we're going to eat up any space, and then we're going to look for the operator. And then we're going to look for another number. So we go to I1, and then we go space, and then we go op is going to be the op parser, and some space, and then I2 is going to be the int parser. And then we'll say I1 op I2. Okay, parser is going to be a parser that returns a count token. It's going to be T plus applied to the character plus. Oh no. Right, okay. So if we find a plus, we want to return T plus. That's something similar to that. It's this governs. So it's going to be T plus. We won't need the space at the end. We're just going to say character, which is a plus. Okay. So does that get the right answer for this particular equation? 1 of 1 passed. Cool. Okay. This is not a very flexible parser. But we'll come back to this later. So I wonder if I could do some kind of, it's not choice because it's like many choice, I guess, or some choice, many choice. How does it work? Are we doing 54? Let's see if we can make this a bit more generic. So it parses a more complex equation. Parses a simple equation. So we will put in our other case, oops, is this one, and it's T1 T plus T mult and T num3. The tokens, and we'll add this in as being another token. Okay, and this should not fail because it's only parsing the start of it. So, is there something in here for like some many? There is a many, okay. It's much faster than many. I don't really care about speed actually. But I can click on this now, I know where it is. What else have we got here? We got choice. Yeah. So I think I can say many choice, but I don't know if that's true or not. Let's find out. Well, first of all, I can say here, I can say choice. Of int parser or op parser. That's going to give me one thing back. And then can we say many? I didn't mean this. I don't think I meant this. Right, what have we got here? Many is applied to too few arguments. What should it be applied to? So choice takes foldable, which is our list, and returns MA. So we'll take a list of parsers and return parser of calc token in our case. And many takes MA, which is up from our choice, right? And it will return list of A by applying it multiple times. Or I could use this alternative actually, I think. Or maybe not, because my choice is a little bit complicated. It's not complicated. Okay, cool. So I can say mini int parser. Where is that symbol? Int parser or alt parser. Okay, what does that give me back for my two things? Okay, now we have a problem with space. So I want to consume the space but not return it. So what can we do about spaces? Skip space. But I want to skip it in an inside alternative. Flexing white space. What does space return? I don't. Oh, what did I do with space here? Maybe space. Oh, that's maybes. Okay, but I could just put space on here, I think. So can I do this? Oops. No, the brackets will help here. Doesn't look like it, to be honest. Okay, why did this work inside the choice, but not here? Oh, sorry, I just want to see if space works on its own. Or if it fails for the correct reason. Yeah, so space is returning. So this returns nothing basically, and I told it to always expect a calc token. So I can match space, but that doesn't help me skip it. So not super useful. Having the space consumer SC. What is SC? Oh, SC is up here. Okay. Right, so this is going to skip over some stuff. It's annoying. I must have skipped space here somehow. But I did it literally, I knew exactly what I was looking for. I mean, I could say something like, oops, to get the number back, and then we could get a space, and then we could just return the number. And then here we could say op is that, and then we get a space, and then we return the op. Drag it slightly further. Yes, it does. Okay, so we break it to mult, but that's because I haven't given that as one of the choices. Okay, it now passes. Cool, so I can now get my list of tokens back. And that's where I'll stop today. So next time I will come back and do the shunting yard thing. Probably take me another hour. And then I'll come back and write the stack machine to evaluate that. But yeah, today was setting up a project and arguing with Megaparsec again. I'm not here next week, so I'm going to be at a conference, so a week off. But I should be back in a couple of weeks, which is some date in July. Can't remember when, like the 7th or something. Not sure exactly when. But yeah, thanks for watching along. And I will see you in a couple of weeks. Goodbye.